Hi everyone. Today we'll have an intro on what is cognitive radio and why we need a cognitive radio. First, we need to understand the spectrum facts. We know that spectrum is a natural resource and we have very limited availability of the spectrum. Further, there is fixed spectrum assignment and bandwidth is also found to be very expensive. Federal Communication Commission has reported that some frequency bands like radio and TV are underutilized, while the other frequency bands like mobile bands are overutilized. This shows that there is inefficiency in the utilization of the spectrum. This necessitates to exploit the spectrum opportunistically. Therefore, we need to dynamically utilize the spectrum, which is called as dynamic spectrum access. Now we need to understand how to achieve this dynamic spectrum access. The solution is we need a clever radio or a clever system. Such a clever radio or system is called cognitive radio. Cognitive radio is an intelligent, adaptive, aware radio system. It can sense its operating environment and change its operating parameters according to the need of the environment. That is, it can modify the system by maximizing the throughput, mitigating the interference and facilitating the interoperability. The main characteristics of cognitive radio are cognitive capability and reconfigurability. The ability of the cognitive radio to sense its radio environment by noting down the variations in it is called cognitive capability. Next, the ability of the cognitive radio to change the operating parameters according to the need of the radio environment is called reconfigurability. Achieving these both characteristics in cognitive radio can be understood in the topic cognition cycle. Coming to the comparison of the conventional radio, software defined radio and cognitive radio, we know the traditional radio system has RF front end, modulation and coding in the hardware portion, while framing and processing alone comes in the software portion. In SDR, RF front end alone is in the hardware, modulation, coding, framing and processing, everything is on the software side. In cognitive radio, it is similar to that of the software defined radio. RF front end is in the hardware, while modulation, coding, framing and processing are in the software. But it includes an intelligent algorithm incorporated in it, which can sense, learn and optimize the changes according to the environment. This is said to be the greatest advantage of cognitive radio. We can understand here that traditional radio is not future proof, while the other two are future proof. We know that cognitive radio is smart and alert because it knows where it is, it knows what services are available, it knows what services will interest the user, what are the current degree of needs and the future needs of the user. It can learn and recognize the usage patterns from the user, and it also applies model-based reasoning. There are a variety of contexts in which cognitive radio can be analyzed. It can be spectrum aware, policy aware, network aware, channel aware and also user aware. The main functions of cognitive radio are spectrum sensing, spectrum management, spectrum sharing and spectrum mobility. The process of detecting the unused portion of the spectrum or spectrum hole, that is, detecting whether the primary user is present or not, is called spectrum sensing. Next, capturing the best spectrum to meet the user's communication requirement is called spectrum management. Then, providing a fair spectrum scheduling method among the cognitive radio users and distributing the spectrum among the users is called spectrum sharing. Next, performing a transition to a better spectrum. That is, when a licensed user is detected, then the vacation of channel occurs. This is called spectrum mobility. Next comes the benefits of cognitive radio. Dynamic spectrum access, that is improved spectrum utilization, is one of the foremost benefit of cognitive radio. The other benefits of cognitive radio includes interoperability and improved vertical handoff, link optimization, better usage of resources, increased capacity and higher data rates, improved coverage and improved link reliability, improved service qualities and low-cost services in low-cost devices. Coming into the applications of cognitive radio, it helps in determining geographic location, identifying and authorizing its user, encrypting and decrypting signals, sensing the neighboring wireless devices, adjusting the output power and modulation channels. The other applications of cognitive radio includes cellular and mobile networks, military applications, and achieving dynamic spectrum access. Last but not the least, we will look into the challenges of cognitive radio. First comes the physical layer challenges, where we try to analyze how to use an available spectrum, how to decide which band to use, how to perform spectrum aggregation, and how to configure different radio networks. Next comes the issues in decision processing, learning process, information collection, modeling, and the type of hardware support. The other challenges in cognitive radio includes the regulatory concerns, the type of adaptations needed, the test and verification methods in cognitive radio, the security issues, cost, size and weight issues, and also energy consumption issues.